Okay, so here's a question from June 2019. It says, Luke is an office receptionist. Each day for 60 days he records the number of people visiting the office. Calculate an estimate of the mean number of people visiting the office. So we have, this basically means that these are grouped data. Okay, these are different groups. So between 0 and 5 people visited on 20 of the days. Between 5 and 10 people, they visited on 14 of the days, okay, and so on. Okay, so this is basically grouped data. So, first of all, to find the estimate of the mean number, we need to sort of have an estimate of the amount of people. We're not given the exact amount of people that are in each of these groups. So, we can do the midpoint of each of these groups, okay. So it gives an estimate about how many people are in each of these groups and how many people are in the frequency. So, the midpoint of 0 and 5 is 2.5. Midpoint of 5 and 10 is 7.5. The midpoint of 10 and 20 is 15. And the midpoint of 20 and 40 is 30. Okay, so here are our midpoints. And then, I know that 20 of the days, there were sort of between 0 and 5 people visited. And we've sort of guessed in that group that sort of 2.5. Okay, this is like an estimate of the amount of people that were there on 20 of the days. So now, what I'm going to do is I'm going to multiply the frequency by the midpoint. Okay, so I do the frequency, which is in this column, multiplied by the midpoint. So I do 20 multiplied by 2.5, which is 50. I do 14. And you can do this all on your calculator, times 7.5 equals 105. Then you can do 11 multiplied by 15, which is 165. And then you can do a 15 multiplied by 30, and that would be 450. Okay, so now you have your frequency multiplied by your midpoint. And then it says your mean number. Okay, and when you work out a mean, you add all of your numbers up, and then you divide by how many numbers that you have. So I know that the total frequency will be 60, as this says it in this question, or you can just add all of these values up. So that is going to be what we divide by, like sort of the amount of numbers that we have. But then we have to add up all of our numbers. So we need to add up all of our numbers here. So I do 50. Add 105, add 165, add 450, which equals 50, add 105, add 165, add 450, and that equals 770. So the total of this column is 770. Okay? And then we need to divide this by the amount of numbers that we have, which is 60. So I do 770. Divided by the amount of numbers we have, which is 60, and that would equal 770 divided by 60 equals 12.83 recurring. So that would be our answer here. It says Luke says the range is 40. Explain why he may be wrong. Okay, so the range, our range is the highest value take away the lowest value. Okay, so the highest value take away the lowest value. And he's saying that it's 40. Well, because we have grouped data, we don't actually know that our highest value is 40. We just know that 15 of the days there were between 20 and 40 people. So our highest value could be 30, or it could be 21. We're just not sure. We're just given a group of values that it could be. We're not given the raw data. Okay, so he could be wrong because it could be sort of 30. So you could say that we are not given exact values. So it could be, it's the same as the lowest value as well. It could be 0 or it could be 5. It could be either one. So we're not actually given an exact value. So you could give an example where we could have a highest value of 30 and then a lowest value of, say, 0, take away 0, and that would equal 30, okay? So because we're not given exact values, you can't say that the range is 40 every single time, but if we were given exact values, then we could find this out. Okay, so here we have a question that is trying to find the estimate of the mean speed. Okay, so the estimated mean of some grouped data. So it says the police record the speed of vehicles passing a speed checkpoint. The speeds are recorded in the table below. So it basically says this is group data. So 5 vehicles had a speed of between 0 and 20. And 8 vehicles had a speed of between 20 and 40. Okay. But then it asks us to try and find the estimated mean, okay? So, we don't know the exact values of how quick the cars were going, so what we're going to do is, we're going to take sort of an estimate, and we're going to take the midpoint of each one of these groups. So, we're going to label this midpoint, and we'll do the midpoint of each of these groups. So, the midpoint of 0 and 20 would be 10. Ooh. The midpoint of 20 and 40 will be 30. Midpoint of 40 and 50 would be 45. Midpoint of 50 and 60 is 55. And the midpoint of 60 and 80 would be 70. Okay, so there are our midpoints. And then what we can do is, then we found our sort of estimate value of the speeds of our car. And then now we're going to multiply our frequency, which is our number of vehicles, multiplied by our midpoint. So we're going to multiply each of these. Okay, so 5 multiplied by 10, which would be 50. 8 multiplied by 30, which would be 240. You can do 37 multiplied by 45 is 1665. They do 47 multiplied by 55 is 2585. And then 3 times 70, which is 210. Okay, so that would be your frequency multiplied by your midpoint. And then it says estimated mean. So to work out the mean, I know that I have to add up all the numbers and then divide by the amount of numbers that I have. So the amount of numbers that I have, the amount of sort of vehicles that I have, is, we already know this, so it's not in the question, so we have to add all of these numbers up. So I do 5, add 8, add 37, add 47, add 3, which would equal 100. And then I need to add all of these ones up, because these are all of our values that we have found. So it would be 50, add 240, add 1665, add 2585, add 210, 4, 7, 50. And then you just do 4, 7, 50, just as you're working out the average, the mean average, divide that by 100, and that would be 47.5, and that would be the estimated mean speed of the vehicles. Put that in there. Okay. So, explain why it is not possible to use the information from this table to calculate the exact value of the mean speed. Well, I know to calculate the exact value of the mean speed, I would actually need each speed of the vehicles instead of just a range of values that they could have been going. So all 5 of these cars could have been going 1 mile an hour, or they could have all been going 19 miles an hour, or they could all be going something different. But we're not actually given exact values of how quickly these cars are going. So our answer to this would be because we are not given exact values, just a range of values that each car was travelling at. Okay, because we're not given the exact values, we're given just a range of values for each one of these vehicles, so we can't work out the exact one. That's why it's an estimate. Okay, so a teacher asked 9 of his pupils how many pets they have at home. Okay, so there's 1, 1, 1, 2, 3, 4, 5, 7, 111. Okay, so one of the students has 111 pets, so they might sort of work on a farm or something like that, but they've got more pets than everybody else. 7 seems quite a lot as well. So the median of the 9 results is 3. The mean is 15. Write down the mode. Well, I know that the mode is the most common value, so the number that is sort of the most common, so the most amount of that value. So I know that there are 3 values of 1 here. There's only 1, 2, 1, 3, 1, 4, 1, 5, 1, 7, and 111. So because there are 3 values of 1, it's the most common value, so I'm going to write 1. And then it says, the teacher wants to use a sensible average, I'm going to underline this, sensible average, to summarise the results. Which average should he use and why? So we want to summarise the results, so it needs to be representative of all of our results. Okay? And that's probably why I'm not going to use the mean, okay? Because it says the mean is 15, but then the mean is larger than all of the values apart from the m1. Because I know that to work out the mean, I'm adding up all these numbers and then dividing them by the amount of numbers that there are. So that means that this 111 is really affecting this average, and I would say it's not representative of everybody's scores. Okay, so what I would use instead was I would use the mean, because basically it doesn't take into account this really extreme value like the mean does. Because just to work out the mean, you put them in order, which they are, and then you find the middle value. Okay, so what I would put here, I would put the median. Because it is not affected by extreme values. Extreme values. Okay. E.g. the 111. Okay. So that is more representative of the data. So the average here, that it's saying for the median, is the average number of pets per home is 3, which is more representative of the data. Okay, so here we have Mr. and Mrs. Wild have 5 children who are all different ages, and that is really important, so we're going to underline this one here. So the mean age is 6.4, the range is 9, the median is 6, the oldest child is 12. Work out the ages of the children, write their ages from youngest to oldest. So in this question, we are given the averages, and then we have to actually work out the data using the averages that we are given. Okay. So I would look at this and I would think, right, what can I write down? What's my first thing that I can write down that's really obvious to me? Well, it says the oldest child is 12. So immediately, I can write 12 in here. Okay. And then it says the range is 9. Okay, so I know that the range is the highest value, take away the lowest value. So I would do 9, so it would be 12. Take away something equals 9. Okay, so 12 take away something equals 9. So I can do 12, take away 9 to find this question mark, which is 3. So I know that my youngest child is 3. Okay. And then it says the median is 6. Well, I know that the median is when I order all the numbers together, I know that it's my middle value. So I can stick this in the middle here. That would be 6. And then it says the mean age is 6.4. Well, I know that the mean, to calculate the mean, I have to add up all the numbers, and then I have to divide by how many numbers that I have. Okay. So I'm going to first work out, I'm going to work backwards. Okay, so I would be adding up all the numbers and then dividing by 5, because that's the number of children that I have. But I want to know, if I was to add up all of these numbers, then what would it have to equal so that the mean age was 6.4? So I'm going to do the opposite of dividing by 5. I'm going to multiply by 5. So I'm going to do 6.4. Multiply by 5. And that would be 32. So I know now that all of my numbers have to add up to make 32. Okay, so I can do 3 add something. So I'm going to call it A, add 6, add, I'm going to call it B, add 12 equals 32. Okay, and then I know that I'm going to add up everything that I know. So I'm going to do 3, add 6, add 12. So 9 add 12 is 21. Then I want to find this value and we've called it A. Then I want to find this value and we've called it B. Okay. And that would equal 32. So I know 21 and then add two numbers equals 32. Well, here I'm going to take away 21 from both sides, okay? Just because I would just want to know what two numbers I have to make the final number in between. So I would do take away 21 and take away 21. So I'd have A plus B. A is just this value I want to find. B is this value I want to find. And that must equal 32. Take away 21 is 11. Okay. So I know that this value here and this value here have to add up to make 11. But using the information that I've got in the question, it says they all have to be different ages. And because they're in order, the first value has to be between 3 and 6. And the second value has to be between 6 and 12. So I need to find two values that add together to make 11. Okay. So I know that 4 is in between 3 and 6. So what do I have to add for 4 to make 11? Well, I know that it'll be 7. And is 7 in between 6 and 12? Yes. So I can put a 4 in here and a 7 in here.